All right, let's take a look at the trends of the periodic table, starting with atomic radius. Before we get into what atomic radius is, let's take a look at something called effective nuclear charge that can help us understand the trends that we see on the periodic table. So on the right side here, I've drawn a Bohr-Rutherford diagram for sodium. And in this Bohr-Rutherford diagram, you will notice there are positive protons in the nucleus, and the dots are supposed to represent the electrons that are all around it. It's important for us to know that there is an attraction that exists between the protons in the nucleus and the electrons that are surrounding it. But naturally, we would expect that that attractive force is less for the valence electron, right? The one valence electron that we see on the very, very outside shell, this electron experiences a less attraction because of these electrons that are kind of in the way. And that's what we call shielding. It's kind of like if you were at a concert, right? Front row, the people sitting in the first row will have a stronger connection to the people on stage, whereas if you're sitting way at the back, all of the people in between you and the person on the stage are kind of getting in the way, right? So the effective nuclear charge is the attraction that the valence electron can feel after all of the shielding that takes place, right? So it says here, the net positive charge from the nucleus that an electron can feel attractions from. The core electrons, which are the electrons that are in between the valence electron and the nucleus, are said to shield the valence electrons from the full attractive force of the protons in the nucleus, right? So because of this, we can explain some of the trends that we see in the atomic radius for a periodic table. So let's take a look at what atomic radius is. If you remember from math class, radius talks about from the center to the very edge of a circle, right? And if you think of an atom as a circle, it's the same thing. It's from the very center. It's the distance from the atom's nucleus to the outer edge of the electron cloud. And knowing this, we can explain or see a trend that exists in the periodic table. So in general, as you're moving from left to right, atomic radius decreases. And let's go back to effective nuclear charge and see if we can explain this. So as you go from left to right on the periodic table, let's take a look at what stays the same. What stays the same are the number of shells between the outermost shell and the nucleus, right? So if that stays the same, what stays the same is the shielding that those electrons are doing between the valence electron and the nucleus, right? So the shielding that exists in lithium is the same as the amount of shielding that exists in neon. However, you'll notice that the number of valence electrons are increasing. So because those are increasing and the shielding stays the same, there is a stronger attraction between the valence electrons and the protons in the nucleus. And because that's true, because of that strong attraction, those electrons get pulled closer and closer to that nucleus. So because of that strong attraction, the valence electrons, those shells, are pulled a little bit closer, a little bit smaller, which is why we see that as we're going from left to right on a periodic table in a particular period, the atomic radius decreases. All right, what happens if we're going down a group, right? Starting at lithium, sodium, potassium. They're all in one group, but lithium is at the top. How can we explain the atomic radius differences here? As you're going down a group, the number of energy level increases, right? We saw in that previous video when we're talking about periods, each row, each period has the same number of shells. But if you're going down a group, each different period has one extra shell. So what ends up happening, there is a greater distance between the nucleus and the outermost shell, right? The electrons on the outermost shell tend to be a little bit farther and farther away. And because they're farther and farther away, right, we know that the atomic radius increases. And because there's more electrons between the nucleus and the outermost electron, or the valence electrons, there is more shielding. Okay, and that is the trend for atomic radius in the periodic table.